Good morning, friends. This video is going to be on how to graph and evaluate piecewise functions. Piecewise functions are various different functions that are all hooked together and we're only using pieces of them. So for instance, one of my piecewise functions that I have here is I have a piecewise function of the linear equation 3 halves y equals 3 halves x plus 2. But I only want the pieces of that function that are bigger and equal to -2. Then I also have the linear equation y equals -x minus 5, but I only want the part of that line where the x's are smaller than -2. So we know that the domain of linear equations is -infinity to infinity, but I only want pieces of those lines. I only want the pieces from -2 greater or -2 lesser, depending on which piece I'm talking about. So the first thing we're going to do is, because this is greater than or equal to -2, I am simply going to remove this x and put -2 in its place. So when I use x to be -2, what do I get? Well, if I put 3 halves times -2 plus 2, I get -1. So I have the ordered pair -2, -1. So if I plot the ordered pair -2, -1, that is this line right here, or that point right there. So then, let's say I want to change that. Instead of being -2, I want something bigger. So what if I go with 0? 0 is bigger. So what if I decide to put 0 in there? If I decide to put 0 in for x, then the y comes out to be 2. So if I plot the point 0, 2, I have that. Well, let's pick something bigger than 0. How about if I pick the number 2? So I'm going to pick the number 2. If I pick x to be 2, then I get 5. And I get 5, so the ordered pair 2, 5, 1, 2, 1, 2, 3, 4, 5, that would be right here. Or I could remember, frankly, that the rise of my line is 3 and the run of my line is 2, so if I go up 3 more and over 2 more, I get this point right here. That would be the point 4. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. That would be the 4, 8. And if I went up 3 more, 1, 2, 3, and over 2 more, I would have this point right here. And that would be the point 6, 11. And then I could, if I wanted to, I could draw my line. But it is really a line segment because it's only a piece of the line. It's only the piece of the line where the x's are greater than or equal to -2. Okay, well, that's enough of that. So let's go with the other line. The other line, I'm going to put -2 in there also. So I'm going to put -2, and I'm going to put -2 right here. And if I put -2 there, and the reason I'm putting -2 is because that's that number, that gives me 2 minus 5, which is -3. So that would give me the ordered pair -2, -3. But because this is an inequality, the point -2, 1, 2, -3, 1, 2, 3 should be an open circle because he is not part of the graph. But then I want smaller numbers. This is lesser, this is smaller. So if I go smaller, -3 is smaller. So what if I change my number to -3? What if I decide to put -3 in here? That would be 3 minus 5. 3 minus 5 is -2. So I would have -3, 1, 2, 3, -2, 1, 2, which would be this point right here. What if I decided to go smaller than that? What if I decided to go -4? Well, if I decided to go -4, so I'm going to put -4 in here. That would be 4 minus 5, which is -1. So -4, 1, 2, 3, 4, -1 would be right here. Or I could remember how to graph lines And the slope is -1, which means it goes up 1 and left 1 every time. And so this line segment would do this. So that is the graph, okay? So basically, because the inequalities center around the number -2, if I were to take a partition, and I were to, if you will, partition off the graph at the line y equals -2, I'm going to have the piece of the first line, which is the pink line, and I'm going to have the piece of the green line. And so that is my graph. And then down here, I want to know what things are. So -5, when x is -5, well, 1, 2, 3, 4, 5. When x is -5, y came out to be 0. When x is -2. Now here's where you need to be careful. For -2, you want to use this one, because that's the one that's actually on the graph. And then when f is 0, we got 2. When f was 4, we got 8. When f was 12, we didn't do 12, but we could do 12. If we did f of 12, we are going to go 3/2 times 12 plus 2. That would be 18 plus 2, so that would be 20. And then if we wanted to do f of 20, f of 20 is 3/2 times 20 plus 2, that'd be 10, so that would be 32. Or what I could have done, if I so chose, is I could have grabbed my calculator, and on my calculator, I could have just typed in y equals the fraction 3/2 x plus 2, and looked at my list. What did it not like? 3/2 x plus 2. Not sure what it didn't like. And there's the entire function. But I only want the table, and I only want the table from -2 larger. So -2 is 1. So there are all my evaluations. So if I wanted to evaluate 12, I get 20. If I wanted to evaluate 20, I got 32. Is that what I got when I did it? Yes, it is. And then, of course, I could return to my calculator, and I could put in the other function. The other function was -x minus 2. And if I graph it, there's the other line, but it's the entire line, not the piece. And then I could do this, and I only want the values that are smaller than 2. So I look at -3, and I get 1 over there. And then if I go to -5, which was the evaluation I was supposed to do, I get 3. So I could have just as easily done it that way as well. So if we return to this one, now I have 3 functions. I have a quadratic function, which is x squared plus 6x plus 3, and I only want those that are smaller than -2. And then I have another function of y equals 1, but I only want that between -2 and 1. And then I have another function, which is a linear equation, which is negative 2x plus 5, but I only want those bigger than 1. So if I go to do this first one, I am going to take and I am going to replace each of these x's with negative 2. So I'm going to put a negative 2 here. I'm going to put a negative 2 here. And that's going to get me 4 minus 12 plus 13. So when I chose to use negative 2, I got 5. So if I go to graph that, negative 2, 5, negative 2, 1, 2, 3, 4, 5. This is going to be an open circle. And it's going to be an open circle because my graph is not equal to. So then let's go and let's change it from negative 2. Let's pick a smaller number. How about negative 3? So let's say I'm going to pick negative 3. So if I pick negative 3, put negative 3 in here, put negative 3 in here, that gets me 9 minus 18 plus 13. That is negative 5. That's negative 4. Let's see. Negative 9 and 13 is positive 4. So that would be the point negative 3, 4. So 1, 2, 3, 1, 2, 3, 4. So I'm going to have that point. How about if I pick a smaller value than negative 3? How about if I pick negative 2? No, I'm sorry, negative 4. I want to go smaller. So now I'm going to pick negative 4. So what if I put negative 4 in here? And I put negative 4 in here. Negative 4 squared is 16. This is negative 24. This is still plus 13. So that is 29 minus 24, which is 5. So I get 5 when I use negative 4. So negative 4, 1, 2, 3, 4, 5. So that's going to be up there. Okay, what if I use a smaller number? What if I use negative 5? Well, if I decide to use negative 5, and the reason I'm using smaller numbers is that's what it says. X's need to be smaller. So I'm going to put negative 5 in here. I'm going to put negative 5 here. And I'm going to put negative 5 here. And that's 25. And that's minus 30. And that's plus 13. So negative 5 and 13 is 8. So I'd get negative 5 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this graph is a quadratic, so it's parabola in shape, and it's going to do this. Let's get rid of all these count marks. So that's my quadratic. Excellent. All right, now I want to do negative 2. That's going to give me the point negative 2, 1. And if I use negative 1, that's going to get me 1. And if I use 0, that's going to get me 1. And if I use 1, that's going to get me 1. And that one needs to be open. And that one needs to be open because that right there is an inequality. So I have this little bitty line segment right here. Okay. Then I need to go bigger than 1. So I'm going to use 1 again. And I'm going to put 1 right here. And when I use 1, I get 3. 1, 2, 3. And then I'm going to use something bigger than 1. How about if I use 2? That's negative 4 and 5. So if I use 2, I get 1. And then if I use something bigger than 1, or bigger than 2, let's say I use 3. So that's negative 6 and 5 is negative 1. So if I use 3, I get negative 1. Or if I remember how to graph lines, I know that my slope is negative 2. That means I go down 2 and over 1, and down 2 and over 1, and down 2 and over 1, and down 2 and over 1. So I would have this line segment. Right there, that's what I would have. So when x was -5, that was the first function, I had an 8. When x was -4, that was the first function, and I got 5. When x was -2, when x is -2, that's the green function, that's 1. When f was 1, that is the purple function. So I'm going to use 3. When f was 2, I got 1. And when f was 12, so if I go back and I put 12 in there, that would be f of 12 is fitting in the equation -2 times 12 plus 5. That's -24 plus 5. That's -19. So this would be -19. And of course, if I don't want to do any of that work, all that work, none of that work, I can go and put it on my calculator. X squared plus 6x plus 13. So let me go get my calculator. Whoops, that's not what I wanted. This is what I wanted. So if I go to my calculator, I can put in what I want. And the first equation was, oh my goodness, things are not cooperating. My first equation was x squared plus 16x plus 13 plus 6x plus 13. The next equation was 1. The next equation was, the next piece was -2x plus 5. The next piece was -2x plus 5. And if I hit graph, there are all three of the graphs. And if I want to look at the table, I want only the first graph, the blue graph in this particular case, for everything smaller than -2, but not including -2. So I want the ordered pair -3, 4. I want the ordered pair -4, 5. I want the ordered pair -5. Then between the numbers -2 and 1, I only want this. You notice all these are 1s because it's a horizontal line. And then once we get bigger than 1, I only want these numbers. And so that's that. And if you wanted to check just the ones that are in the question, you could change your window. No, we're going to change your table set. And you could change it from auto to ask. And hit enter. And now when you look at your table is blank. And then the numbers I was supposed to evaluate are the numbers -5, -4, -2, -5, -4, -2. So I could type in -5, -4, -2. The other numbers I wanted to evaluate were 1, 2, and 12. So if I would put in 1, 2, and 12. So there are all of those. And then I just need to make sure I'm in the right function. So for -5 and -2, I wanted 8 and 5, which if you'll notice, 8 and 5 are what I have. For -2, I wanted the middle function. So for -2, I wanted the middle function, which was 1. And for 1, 2, and 12, I wanted the last function, which is 3, 1, and -19, which is what I have over there. So how you do it by hand, how you do it by calculator, all of that is well and good. By the way, if I stick with what I was doing earlier, my numbers are -2, 1. So if I were to take my partition, my vertical lines that partition, the reason they're functions is because when I drop the line y equals -2 through here, y equals -2, you see I only hit here. I only hit on the green function because the pink function is an open circle. Then the other vertical line I would have is the line y equals 1. And when I drop my line y equals 1 through here, that's the line y equals 1. It remains a function because I only get to count the purple function for when x equals 1. I don't count the green function when x equals 1. So it still passes the vertical line test. So that's why it's called a function, and it's called pieces, because this one, for instance, has 3 pieces. And it all comes from paying close attention to these inequalities. All right, my friends, that is everything there needs to know about piecewise functions. If you have any questions, ask me in class or send me an email.